Hey everyone, today we're going to be talking about rational expressions. We're going to look at the domains, how to simplify simple rationals, multiply, divide, add, and subtract. And as you go through the video, please pause as needed, and I suggest that you try to give yourself an opportunity to try the problems and then continue on. So in terms of simplifying the expressions, we want to factor when possible, look at the domain, and then cancel common factors. So let's take a look at an example here. Okay, so these first two examples, we got 7 over x plus 5, and then x over x squared minus 36. There's nothing to factor here, can't cancel anything, so this is in simplest rational form, and now we just want to try to figure out what the value of the domain that would be excluded. Remember, with rationals, we look at the denominator and set each factor equal to 0. So if you set that equal to 0, x could not equal negative 5. And remember that we're doing domain in terms of interval notation, so this would be from negative infinity to negative 5 with a parenthesis, union negative 5 to infinity. On the second one, we will need to factor. So if we look at x squared minus 36, we can say x plus 6 and x minus 6. That is a difference of squares problem. So here x could not equal plus or minus 6. And our domain would be as follows. We would have 3 sections from negative infinity to negative 6, union negative 6 to 6, and then union 6 to infinity. Okay, in terms of simplifying here, we will be able to cancel a term. So if we look at the numerator, we can take out an x squared for this first one, so it's x to the third plus 3x squared. If we take out an x squared, that would leave you with x plus 3, and then over x plus 3. And if you notice, we have a common factor here in both numerator and denominator, so we can cancel those factors out, leaving with x squared as the final simplified answer. Now, in terms of the domain, you always want to go back to the original, and even though we've canceled out this term, negative 3 is still excluded from the problem. So you have to remember to always refer back to the original problem, because here there's no more fraction, so it looks as though it might be a polynomial. However, the original problem was rational, so we do have to consider that. So your domain for this one, again, would exclude negative 3 as the only value, but everything else would be included. So negative infinity to negative 3, union negative 3 to infinity. Same idea over here. We've got x squared minus 1 over x squared plus 2x plus 1. Factoring the numerator, we have a difference of squares, so minus 1 and plus 1. And in the denominator, two things that multiply to be positive 1, add to be 2, would be positive 1 and positive 1. And you could write that as x plus 1 squared if you wanted to, or write it out separately. Sometimes it's easier to see it when you're doing rationals that if you write it out separately, because we can easily see here that we've got a common term here and here. You can only take one from the numerator and one from the denominator. You cannot cancel out both of those values. And so simplified answer, would be x minus 1 over x plus 1. And then the domain, x cannot equal negative 1. Okay, so if you said both x plus 1 and x plus 1 equal to 0, you're going to get only negative 1. Remember that we don't worry about the numerator, only the denominator. So domain would be from negative infinity to negative 1, union negative 1 to infinity. Okay, so that's when we've got just one fraction here. When we start to get a fraction being multiplied or divided by another fraction, again, you want to make sure you factor every single numerator and denominator completely. That's very important that you factor completely. If we are working with division, we need to make sure that, down here, we would make sure that we would multiply by the reciprocal. And just like we did on the last one, if you have any common terms, we can cancel. Okay, so factor completely, is that first step, and then make sure that you cancel anything that has common terms. Again, only one from the numerator and one from the denominator, and then anything remaining would be your answer. Okay, so let's take a look at these, or this next example. So this one we've got, it says multiply or divide, and we have the multiplication there. So kind of starting in the top left, we see if we can evaluate anything here or factor. With this just being x plus 3, there's nothing we can do. So I'm just going to rewrite this here as x plus 3 in the top left. Looking at this denominator, again, we've got a difference of squares problem. We'd have x minus 2 and then x plus 2. And then we can factor both the numerator and denominator here. This would give us x minus 3 and x plus 2. Two things to multiply to be negative 6, and then add to be negative 1, negative 3, and positive 2. And then for this last one, again, we do have a perfect square here, so if you wanted to write squared, you could, or you can write it out as x plus 3, x plus 3. It's a little bit easier to see if you write it this way. So again, as long as there's 1 in the numerator, 1 in the denominator, we can cancel. So you see we've got x plus 3, x plus 3. Doesn't matter what fraction it falls under, just has to be 1 from the numerator, 1 from the denominator. And we also have x plus 2 and x plus 2. So if we write this as one fraction, this leaves us with x minus 3 over x minus 2 times x plus 3. You can go ahead and leave it unfactored. It gives you one less step that you have to worry about. That would be the simplified version. And then we got to figure out our domain. So again, we need to go back to the original. Even though we've canceled some terms out, we have to think about what x is not allowed to be. So if we look at all the denominators here, it cannot equal positive 2, cannot equal negative 2, so plus or minus 2. And then here, these are both positive, so x cannot equal negative 3. So we're going to actually have 4 sections for our domain, starting with the lowest value. So it's going to go from negative infinity to negative 3, negative 3 to negative 2, negative 2 to 2, and then 2 to infinity. So again, can't be positive or negative 2 or negative 3. Okay, so very similar problem here, except this is division. All right, so for division, again, we're going to keep the first fraction the same, and then flip the second fraction, multiplying by the reciprocal. So as I do this, I'm going to factor as well, just to save some time. So this would end up being, you could write it as x minus 1 squared, but I'm going to write it as x minus 1 and x minus 1. Here we can take out just x, leaving you with x squared plus 1, and you can't do anything more with that, just because this is a positive. Remember, in order for it to be different, it has to be difference of squares if you want to go further with something like that. Excuse me. And I'm going to flip this fraction as well, so remember that these two are going to interchange. So I'm going to factor this and write it in the numerator location. So we can take out a 3, leaving you with x squared plus 1. And then here, two things that multiply to be negative 2, add to be 1, would be x plus 2 and x minus 1. So if we look at it, we can cancel out the plus x squared plus 1 and x squared plus 1. And then we can also cancel out the minus 1 and minus 1 here. Okay, so again, we do kind of want to look at the original, but we have to keep this in mind for our domain, since this did go to the denominator here. So if we look at the original, these have very similar denominators. This one we took out x, and that would be x squared plus 1. Here we took out a 3, and we still have the x squared plus 1. And so if we look at that, x can't equal 0 from this one, and there's actually no restriction here. Even if you had any value, if you were to square it and then add 1, there's no way for that to be 0. So we kind of ignore anytime we have x squared and then plus a value. It's not going to affect the domain. So x can equal 0. Again, that's from the value we took out right there. Now we look at this domain, or excuse me, this denominator. It cannot equal negative 2, and then it also can't equal positive 1. All right, and so those are the 3 values that we would have. And again, writing this in order, so we have our domain negative infinity to negative 2, union negative 2 to 0, union 0 to 1, and then 1 to infinity. Okay, so that's through multiplication and division. Last part here is the addition subtraction. Again, important with addition and subtraction is you have to find LCD. You don't have to do that with multiplication and division, but here you do. So identify the LCD first, and then multiply whatever you need to multiply to make each fraction have that common denominator, and then just deal with the numerators. Make sure that you're going to combine like terms for the numerators. and then simplify if possible. So when looking at this first example, you see that they already have common denominators, so don't really have to do anything. But what sometimes trips people up is this minus here. They forget to subtract both of those values. So it's kind of helpful if you just put some parentheses down there. Just remember to distribute the negative. So I'm going to write this as one fraction as x minus 3x and then minus 2. And again, that's distributing the negative over x plus 1. And if we simplify, that's going to give you negative 2x minus 2 over x plus 1. Alright, and now we've simplified this. You always have to evaluate and say, can you factor anything? Or if you look here, we can take out a negative 2. When you do that, you're going to be left with x plus 1 with a negative 2 on the outside, and then also an x plus 1. And these will cancel. So this entire problem actually does simplify to just get negative 2 as your answer. Okay? If we were looking at domain, you would say that x could not equal negative 1. Okay? And then final example here. We've got 3 over x plus 1 and then plus 5 over x minus 1. So even though these things look like the denominators have a lot in common, they each have an x, they each have a 1. One of them is positive and one of them is negative, making them different values. So your your LCD here would be x plus 1 and then times x minus 1. So take the first fraction and we need to multiply by what it's missing, and in this case is x minus 1. So top and bottom need to get multiplied by that value. And then plus 5 times x minus 1, and then this fraction would need x plus 1. Okay, so go ahead and distribute in the numerator. That's going to give you 3x minus 3. And I'm going to make this one fraction. And over here is going to give you 5x plus 5. And then again, we've got the denominator of x plus 1, x minus 1. Feel free to FOIL that if you want to, but it's honestly easier if you just leave it factored, because you might be able to cancel later, and it's just one less step you have to worry about. Okay, and go ahead and combine like terms in the numerator. That gives you 8x plus 2 over x plus 1, x minus 1. Now you can leave this as your answer, and the reason we don't really have to factor out the numerator is because it won't cancel or anything. But if you want to, that's fine. You can take out a 2, and so we could say or, take out a 2 from the numerator, leaving you with 4x plus 1 over x plus 1, x minus 1. And both of those are completely acceptable. You don't have to factor because nothing will cancel.